One of the major responsibility of link layer 2 in OSI model as well as in SS7 stack is detection of errors in the transmitted packet. It's a very useful thing because the network is prone to errors, and detection of such errors would warrant retransmission of packets. And one of the techniques used for detecting errors in the packet is cyclic redundancy check. It's an algorithm applied on the payload, on the main signaling unit that is transmitted, uh, and you can say a CRC code will be obtained after applying that algorithm on the signaling unit, and that is appended along with the transmitted data. And on the receiving end, the entire signaling unit along with the CRC code is applied with the same cyclic redundancy check, and in this way both the sides in this way the receiver will verify that the packet has been received without any tampering or with just error free. So this CRC technique, now in this process for calculating the CRC, flag is not included, only the signaling unit is included, and after applying the CRC algorithm on signaling unit, it is appended after the signaling unit. Now let us take an example of CRC check. So in the cyclic redundancy check, the main factor, you can say, there is a polynomial function used for calculating the CRC, and this polynomial function is a representation of a bitmap. Okay, so in this example, on the transmission side, the polynomial function chosen is x to the power 3 plus x plus 1, which is basically the polynomial representation of 1011. Now how it comes to 1011 is very straightforward. As you can see, x to the power 3 is basically the fourth bit. The fourth bit should be 1, and then x stands for x to the power 1, which is second bit, that has to be 1, and then 1, which is the 0th bit, that has to be 1. Rest all bits should be 0. So in this way, the power to the x it basically represents the position of bits that will be 1 in that bitmap. So the bitmap is 1011. Now this 1011 is XORed with the data bits, with the you can say the main payload, and this is applied on the data bit in a sliding fashion. So let's say first 4 bits of the data bits will be applied with will be XORed with the bitmap. The result is again applied with the bitmap, but shifted to the last one's position, and then again this process is continued till we find that the number obtained is less than the bitmap itself. So here in this example, you see the first 4 digits are 1000, and it is XORed with our bitmap, which is 1011, and then the answer is obtained 0011. Okay, and then rest of the bits are unchanged. Then our bitmap is XORed with the latest one. Okay, it will be shifted to the latest one, and then these 4 bits are XORed. So we take down 00, then 110, after XORing it comes to 0 0 0 1 0 1 0 0. And okay, here also you see that 3 digits of CRC has been appended as 0 0 0. Okay, so the entire processing on the data bits will start after appending 3 bits of CRC. Okay, so if the data bit was 1000 10000, then it will be the data bits and after that 3 zeros for the CRC. Okay, now this process will continue. So now here you see in this way, so we have the latest bit is 1010. This will be XORed with our bitmap, and then the answer obtained is these 6 zeros and 1 0 0 0 0. Okay, now the latest bit is over here. This is, so XORing will happen from here. So 1011 is XORed against it, and finally the answer obtained is 110. This 110 is less than 1011, so this XORing process will stop, and this will be our CRC code which will be sent in the transmitted data. Okay, so the transmitted data is this. Okay, now this transmitted data is received as it is on the reception side. Now here you see the transmission side and the reception side, they both should agree on the same polynomial function to be used for the CRC check to happen successfully. So since the reception side also knows the polynomial function, so it will start with the whole received data and start applying the bitmap one by one, and this bitmap will continue on the same fashion with the latest one. It will be XORed with the bitmap and the result is obtained. After result, it is again applied with the latest one, and then the result is obtained. This process will continue till we get the number which is less than our polynomial bitmap or polynomial function. So since this time the transmission was successful, so in the end we will get all zeros, and presence of this all zeros in the CRC check will signify that the transmission has been successful. In the in the MTP2 layer, the polynomial function used is x to the power 16 plus x to the power 12 plus x to the power 5 plus 1. At the bitmap level, it is a 16-bit bitmap which is applied on the entire signaling unit, and the CRC is calculated, but the basic process remains same as in this example.